The texture of spacetime may not be able to keep up with the speed of this process, and it could tear apart. This unsettling event is unfolding right now, captivating astronomers around the world. The massive red supergiant, Betelgeuse, located on Orion's shoulder, is undergoing a monumental transformation. Its radiance, the brilliant glow that defines its presence, has undergone an extraordinary surge, surpassing its usual brightness by an astonishing 50%. Earlier this year, Betelgeuse held the title of the 10th brightest star in the night sky, but this unexpected stellar outburst has pushed it to a new rank, now shining as the 7th brightest star in the sky. Betelgeuse, a massive star nearing the end of its life, is of immense size. If it were placed at the center of our solar system, its outer layers would extend all the way to Jupiter's orbit. Eventually, the star will collapse, leading to a powerful supernova explosion, which could result in either a neutron star or a black hole. The excitement surrounding Betelgeuse's eventual explosion comes from the fact that it will be a rare event, located about 650 light-years away. Humanity finds itself in a prime position to witness this cosmic spectacle firsthand. When the supernova occurs, it will create an incredible display of light. Initially, there will be a burst of neutrinos that will travel across Earth, detectable by observatories around the world. Following that, high-energy photons will escape from the expanding cloud of debris, causing Betelgeuse to rapidly increase in brightness over a span of 7 days, reaching up to 100,000 times its normal luminosity. Depending on the strength of the explosion, this stellar outburst could rival the brightness of a full moon and may even be visible during the day, casting distinct shadows. This extraordinary event will last for an extended period, offering an unprecedented opportunity for detailed observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse may stir speculation and concern due to the historical association of such events with ominous signs, we can find comfort in knowing that we are far enough away to be safe from any harmful effects. To fully understand the mystery of Betelgeuse, we must look back to late 2019 when certain anomalies first became apparent. During this time, the red supergiant star began to experience significant dimming, a change visible even to the naked eye. Observations using the Very Large Telescope in the optical range revealed that Betelgeuse appeared relatively stable, but its photospheric layers showed signs of considerable disturbance. The photosphere represents the outer layer of the star from which light is emitted. Scientists also noticed a swelling of the photosphere, making it appear as though the star was expanding. This expansion continued at a consistent rate of about 8 kilometers per second for much of the year, until mid-November 2019, when the outward movement began to slow. By this point, the flow of material from Betelgeuse stopped, prompting astronomers to capture new optical images of the star. Their observations revealed 2 surprising irregularities. First, a darkened region appeared on the star's southern hemisphere, contrasting sharply with earlier images taken at the beginning of the year. Additionally, the star's surface temperature dropped by around 80 Kelvin between January 27 and February 13, 2020, and its brightness reached a remarkable low. Roughly a year after this dip in brightness, the star gradually regained its typical luminosity over the following months, returning to its normal state. This led to the question, what had actually happened to Betelgeuse? All available evidence strongly suggested that Betelgeuse had undergone a massive and exceptional event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better understand SMEs, imagine a volcanic eruption of a scale comparable to a star. Material from inside the star surges upward and outward, creating shock waves within its atmosphere. Over time, this material forms atoms and dust, partially obscuring our view of the star and making it appear dimmer. In the case of Betelgeuse, the SME resulted in the release of a mass 400 billion times greater than what is typically seen during similar events on other stars. This mass was several times the size of the Moon and was ejected at extraordinary speeds. Scientists noted that such a massive mass ejection from a star's surface had never been observed before. This event allowed for the direct observation of the star's surface details using the Hubble telescope, offering a rare glimpse into the aging and evolution of a dying star. The ejection caused a significant loss of mass for Betelgeuse in a single event, which demonstrated that a dying star can experience substantial mass loss beyond its usual yearly decline due to the solar wind. It was as though Betelgeuse had violently expelled its outer layer, and was in the process of slowly recovering from the aftermath. After this darkening event, Betelgeuse's behavior shifted. Previously, it would pulse or change its brightness every 400 days due to fluctuations in its size and temperature, but now it is pulsating at shorter intervals. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to changes in its size and temperature. This red supergiant is known to show two primary periods of light variation, one lasting 400 days, believed to be caused by pulsations in its major mode, and another period, which lasts approximately 5.6 years, with its origins still unclear. In their research paper, scientists used computational models to gain a deeper understanding of the events that occurred. They proposed that an unusually hot gas bubble, resembling a giant and intense pocket of hot gas, emerged from deep within the star. These hot gas bubbles are sometimes formed by the star's violent and convective outer layers, akin to a pot of boiling soup where the material is constantly stirring and mixing. As this hot gas bubble rose and broke through the star's surface, it triggered the release of stellar material. Interestingly, it also disrupted the star's usual pulsing pattern. The star's surface continued to expand, while its deeper layers contracted, causing a shift from the normal 400-day pulse cycle to a new, shorter 200-day pulse cycle. Astronomers believe that the star's normal behavior will gradually stabilize, with the unusual pulse pattern returning to a more regular state over the next 5 to 10 years. Betelgeuse is nearing the end of its life cycle, characterized by its enormous size and unstable nature. Its diameter is estimated to be about 1,000 times that of our Sun. Despite its massive size, Betelgeuse is not a stable star. It pulsates and fluctuates in brightness over time, reflecting the internal turmoil and its impending death. One of the most fascinating aspects for astronomers is Betelgeuse's potential to undergo a supernova explosion. While the exact timing of this event remains uncertain, experts believe it could happen anywhere from 10,000 to 100,000 years from now. As Betelgeuse exhausts its nuclear fuel, especially during its fusion process from helium to heavier elements like carbon, oxygen, silicon, and ultimately iron, its core will collapse under its own gravity. This catastrophic collapse will trigger a powerful explosion, releasing vast amounts of energy and matter into space. The resulting supernova would be an awe-inspiring spectacle, visible even from Earth, despite Betelgeuse's distance of about 650 light-years away. Such an event would briefly outshine all the stars in the Milky Way and could potentially leave behind a neutron star or even a black hole, depending on the star's initial mass. Astronomers are closely monitoring Betelgeuse, tracking its fluctuations in brightness and other changes, looking for signs of its imminent demise. Recent observations have revealed intriguing insights into its variability, including changes in its pulsation patterns and surface features. In addition to its scientific significance, Betelgeuse holds a prominent place in human culture and mythology. Its name derives from the Arabic phrase Yad al-Jawza, meaning the hand of Jawza, referring to one of the stars in Orion's constellation. Across various cultures, Betelgeuse has been associated with different symbols and meanings, reflecting its prominent position in the night sky and its influence on ancient societies' beliefs and practices. In ancient Egypt, Betelgeuse was linked to the goddess Isis, representing resurrection and renewal, while in Norse mythology, it was associated with the heart of the giant Hrungnir, symbolizing strength and resilience. These diverse interpretations highlight Betelgeuse's widespread appeal and its role in shaping human narratives about the cosmos. Advances in technology have allowed astronomers to study Betelgeuse in unprecedented detail. Tools such as the Hubble Space Telescope and ground-based observatories equipped with cutting-edge spectroscopic and imaging capabilities have provided valuable data on Betelgeuse's surface properties, chemical composition, and stages of evolution. Recent research has also focused on its mass loss mechanisms and the impact of its stellar winds on surrounding interstellar material. These findings enhance our understanding of how stars evolve and interact with their environments, shedding light on the broader processes that shape galaxies and cosmic evolution. Furthermore, Betelgeuse's variability offers insights into the underlying physics of stellar pulsations and instabilities. By studying how stars like Betelgeuse pulsate and change in brightness over time, scientists can refine models of stellar structure and evolution, improving our ability to predict the behavior of other stars throughout the universe. Beyond its scientific and cultural significance, Betelgeuse continues to capture the public imagination through popular media and entertainment. Its portrayal in literature, films, and art reflects its status as a cosmic icon and a symbol of astronomical wonder. From science fiction novels exploring the implications of supernovae to blockbuster films depicting distant worlds and interstellar journeys, Betelgeuse's impact extends far beyond the realm of cosmology. Looking ahead, astronomers will continue to monitor Betelgeuse's evolution and fluctuations, awaiting future observations that could provide further clues about its ultimate fate. Whether Betelgeuse will indeed undergo a supernova explosion within our lifetime remains uncertain, but its ongoing transformation offers an exciting opportunity to expand our understanding of the universe and our place within it. In conclusion, Betelgeuse stands as a testament to the remarkable complexities of the universe. From its immense size and variability to its cultural significance and potential for a dramatic supernova, Betelgeuse continues to challenge and inspire astronomers and enthusiasts alike. As humanity continues to explore and unravel the mysteries of the cosmos, stars like Betelgeuse serve as beacons of discovery, reminding us of the dynamic and ever-changing nature of our vast universe. Scientists have been examining the possibility of a supernova explosion from Betelgeuse, with some suggesting that it could happen within the next 10,000 to 100,000 years. This estimation is based on factors like the star's size, luminosity, and age. Betelgeuse is currently in the early stages of helium fusion into carbon, a process that will continue with oxygen, silicon, and eventually iron, before the star's core collapses under its own gravity, leading to a catastrophic explosion. Since Betelgeuse is located 650 light-years away, any supernova event would only be visible to us after a delay of 650 years, due to the limitations of the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise in our lifetime. One fascinating aspect of Betelgeuse is that we can actually observe its surface, which is not usually possible with other stars. This gives us a unique opportunity to study the behavior of massive stars as they age and undergo explosive events. Recently, astronomers made an exciting discovery when they observed a star consuming its own planet, located 12,000 light-years away in the constellation of Betelgeuse. Betelgeuse, with its distinctive name and prominent position in the night sky, has captured human imagination for centuries. Its name, derived from Arabic, was originally interpreted as the armpit of the giant, though some scientists believe it could refer to the hand or shoulder of the giant. This connection to physical body parts is reflected in various cultural interpretations of Betelgeuse, including its representation as a severed limb in Japan and as a turtle's leg or a caiman's foot in Brazil. In Sanskrit, Betelgeuse is associated with the Wet One, linked to the Hindu deity Rudra and the storm god of the Ardra lunar house. Throughout history, Betelgeuse has held significant cultural and symbolic meanings. In Macedonian customs, it represented domesticated animals and agricultural life, while in places like North Island and the Melville Peninsula, its rise marked the beginning of spring and longer days. Betelgeuse's cultural prominence is tied to its position in the Orion constellation, where it is seen as the star on Orion's right shoulder, one of the brightest stars in the sky and ranked 11th in luminosity. This has inspired countless artists, scholars, and creators over the years. In recent times, Betelgeuse has undergone remarkable changes, attracting the attention of astronomers worldwide. These include notable dimming events and massive surface mass ejections. Betelgeuse's behavior has led to unprecedented observations, highlighting its potential for dramatic changes, including a potential supernova explosion. While the explosion of Betelgeuse would be a breathtaking event, it should not cause alarm, as humanity would not be endangered by it. The death of a star offers a rare opportunity for scientists to study the life cycle of stars, the mechanisms behind their explosions, and the formation of new cosmic structures. It serves as a reminder of the universe's dynamic and ever-changing nature, encouraging further exploration and a deeper understanding of the cosmos. Betelgeuse's transformation signifies the end of a star's life and its rebirth in a spectacular burst of light, continuing to captivate astronomers and the public alike. Also known as Alpha Orionis, Betelgeuse remains a focal point for scientists due to its unique behavior and its important role in advancing our knowledge of stellar evolution. Positioned prominently in the Orion constellation, it not only has cosmic significance but also carries cultural and mythical importance across centuries. As a red supergiant, Betelgeuse's fascinating life cycle continues to intrigue both researchers and enthusiasts.